So by keeping the concept of inverting comparator and the non-inverting comparator, we will understand what is meant by a window comparator. So if you just observe the circuit diagram of the window comparator, it is the combination of inverting and the non-inverting. See here, we are giving input. See, this input voltage has been distributed to both the op amps. Okay, this input voltage, that is Vin. Vin is nothing but the input voltage. It has been given to inverting terminal, and this input voltage same is given to non-inverting also. So therefore this is an inverting comparator, this is a non-inverting comparator, and another input is LTP, that is called as a lower threshold point, and another input for this op amp is UTP, that is a upper threshold point. So now after looking this circuit diagram, what are the components are required in order to build or to in order to implement this window comparators, you require 2 op amps and 2 diodes, that is D1 and D2, and one more resistor, that is 10 kilo ohms. So now, the input voltage, that whatever we are applying here now, that input voltage is a sinusoidal waveform. Okay, sinusoidal waveform. And what is the amplitude of that sinusoidal waveform is 10 volts. So this will be 5 volts and here it will be minus 5 volts. So peak to peak means what? From this peak to this peak it is 10 volts. Okay, so here it will be plus 5, here it will be minus 5, but from peak to peak it will be 10 volts. So 10 volts peak to peak sinusoidal waveform is applied to input voltage. See, these terms are little bit electronics terms, try to understand. So what is your input voltage? Your input voltage is a sinusoidal waveform, and that sinusoidal waveform is 10 volts peak to peak. What is this 10 volts peak to peak andre? From this peak to this peak it is 10 volts. Of course, the upper half is plus 5 and this lower half is minus 5, but we usually call from peak to peak it is 10 volts. Okay, so this sinusoidal, that is a 10 volts peak to peak, is applied as an input voltage. So now this LTP, let me assume this LTP as 2 volts. Okay, let me assume that LTP as 2 volts and this UTP as 4 volts. And the upper threshold point 4 and lower threshold point 2. So now this is 0, right? This is 0, this is 5. 0 and 5 madhya 8 volts barutte. This will be 1, 2, 3 and 4. So from 2, okay, from 2 to 4, whatever the voltage is there, okay, that voltage you will be getting at the output. That's why it is called window comparator. Okay, whatever the voltage that is there between 2 and 4 you will be getting here as output. Similarly, here also you will be getting this is your window comparator. Okay, this is 2 and 4. Write down the dotted lines and write down the so this is your waveform. So how you have got this square wave? How you have got this square wave is, so it will be passing only the voltages between 2 and 4. Okay, it will be, I repeat once again, it will be passing the voltages only between 2 and 4. Whatever the voltage that is there between 2 and 4, that will be passed. So that's why only at that area you will be getting the square wave. Okay, so that is why it is called as a window comparator. It will be having some window like a thresholds. So 2 and 4. Even 4.5 tagondre here, 4.5 and here 1.5 tagondre, it will be passing the voltage between 1.5 and 4.5. Okay, here also. See here, see 0, 1, 2, 3, 4, 5, again 4, 3, 2, 1, 0 like that. It moves on. So this is a window comparator. Always remember, it requires 2 op amps, 2 741 op amp and 2 diodes and 1 resistor. So here you are applying the input voltage, which is a 10 volts peak to peak sinusoidal waveform, and I am assuming that upper threshold point as 4 and lower threshold point as 2. So when I am assuming this threshold points, whatever the voltages that comes between these 2 and 4, only those voltages will be passed. So that's why it will be high at that particular point and remaining points it will be low. So finally you will be getting like this. Okay. Okay, all these things you can look into the circuit, look whenever we are doing the implementation. Understood? Please take down this neatly. You can write down these dotted lines in order to write the square waveform properly at that position. If dotted line bardinandre is square ilello. If you are writing square somewhere, then there will be no sync between the input and output. In order to have a proper sync, we are writing the dotted lines. There is no compulsory, but if you are writing, then your graph will look clear and neat. Okay.